Hey, this is Mr. Warden, and this is a video key for Geometry Exit Ticket 24.1. And let's go right into the proofy stuff. So which triangles would you want to prove are congruent to help us prove that RT is congruent to RS? All right, so this is RT and this is RS. And they are part of triangle RPT and triangle RPT and RPS. So that would be the triangles you'd want to prove. So I'm just going to say it. We want triangles RPT and RPS. Because then we would be able to figure out, we could prove these triangles are congruent, and we could prove RT and RS are congruent using corresponding parts of congruent triangles are congruent, or kappa kappa. Now we can easily prove that PR is congruent to PR by the reflexive property. But what would allow us to prove that PT is congruent to PS? So that's going to require us to take a look at the givens. So we've been told that triangle ABC lies on plane M. Cool. That's nice to know. And we've been told that PA, let's label that. Sorry for the yawning. It is late. PA is congruent to PC. We've also been told that AB, actually we use a different color for that. Okay, we've been told that AB is congruent to BC. Okay, that doesn't seem to get at what we need to prove that PT and PS is. But these two green lines are promising because those are congruent and PT and PS are parts of those. So now let's look at the next one. T and S are midpoints. So T and S are midpoints of congruent segments. Since they're midpoints of congruent segments, then they cut congruent segments in half, giving us congruent quotients by the division property. So by the division property, we can conclude that PT is congruent to PS because they are halves of congruent segments. Okay, so now we can actually prove that, I'll grab a different color for this. We can prove that PT and PS are congruent, and we already could prove that PR is congruent. So now we have a side and a side, side and a side. Cool, that's useful. We don't have enough. We can't do side, side, side because RT and RS are the things we're trying to get. So we can't prove these little triangles are congruent by side, side, side. But we have two sides, and now we have this way to prove that PR and is PR because that's reflexive, and we can prove that PT and PS are congruent. So we almost have it. If we could prove angle RPT was congruent to angle RPS, then we would have side angle side. We could prove that RPT and triangle RPT and triangle RPS are congruent, and then RT and RS are congruent by kappa kappa. So how could we prove that angle RPT and RPS are congruent? Well, the neat thing is they're also the top angles of PBA and PBC. And we already know a couple of things. We know from earlier that PA and PC are congruent. We also know from earlier that BA and BC are congruent. And I gave you a little bit of a hint when I told you PR was congruent to PR. We can also say that PB is congruent to PB. And that means that we can prove that triangle PBA and PBC are congruent. So since PBA is a triangle, I should say, triangle PBA, type PBA is is congruent to triangle PBC by side, 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 we can say angle RPT is congruent to, in the case of this triangle, would say BPA, but that's the same angle as RPT. So I'll say BPA is congruent to angle BPC by Kappa-Kadaka, and those are just different names for angle RPT and angle RPS. Okay, so then we would be able to prove, so now we'd be able to prove that triangle, I'll go ahead and label that, the triangle RPT is congruent to triangle RPS by side angle side. Okay, so now we would be able to prove side angle side, and by that we'd be able to prove RT and RS are congruent using Kappa-Kadaka. I'm going to make a note there. After that, we could prove that triangles RPT and RPS are congruent by side angle side, and therefore RT is congruent to RS by Kappa-Kadaka. And so that would be everything you needed. You just had to organize it in a logical flow, but these givens lead to all that stuff. Just to recap, it would be useful to prove that RPT and RPS are congruent in order to prove that RT and RS are congruent. And then in order to prove PT and PS are congruent, it helps to remind ourselves that PA and PC are congruent and that T and S are midpoints. So we're just dividing congruent things in half, getting congruent halves. Then we can easily prove that these triangles, PBA and PBC, are congruent by side, 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 and that leads us to this angle, our BPA, which is the same as RPT, being congruent to BPC, which is the same as RPS. And so then we get side angle side, which will give us these two little triangles, RPT and RPS. And then we've got RT and RS by Kappa-Kadaka for the win.